Okay, folks, so the long-awaited showdown has finally come. This is the MPD workbook that I am using when I am delivering the course on managed pressure drilling and well-controlled dynamics. As you can see that this workbook has got a bunch of tabs in there. The first one, which is called the Data MPD Study, it's to do with the candidate screening form for managed pressure drilling. In fact, it is now called, I should be changing the name, it should be called Data Capturing Template for MPD Operations. And you can see that I have divided the MPD operations into 3 different tier types. However, the pressurized mudcap drilling, the floating mudcap drilling, and DGD, the dual gradient drilling technology, are also in the same arena of MPD, but I consider PMCD, FMCD, and DGD into dual density drilling sort of applications. So anyway, just to briefly go through this data capturing template, these are all the drivers where you can apply MPD. And then obviously you've got the information that you have to plug in here in terms of formation data, if it is a top hole, reservoir, and if it is in the actual pay zone, what type of characteristics of the fluid that you can encounter. The production history is to do with the risk analysis and the way you need to drill the well. And then finally, there's a little bit of information on the well and drill string design data. This SP hydraulics program, SP stands for single phase hydraulics program. So basically I've been arguing for quite a bit of time now that you do not really need a software when it comes to designing MPD wells, or if you have to analyze an open hole section which has been screened out as an MPD candidate. You don't really need a software for that. However, what I'm doing as I go along, I'm actually updating and adding some more features into this workbook, in particular with this single-phase hydraulics program. But this is just to show you a glimpse of the single-phase hydraulics program. You can see here, this is all to do with the drill string configuration data. That's to do with the general data requirement, the fluid data here, well construction and volumes, and the area here, that's to do with the pressure losses. And remember, when it comes to MPD, we are only interested in the annular side of the well. So therefore, drill string pressure losses would have got nothing to do with us. But here it's what is drives the BHCP and the ECD that we are looking at. Don't worry about these variables here. I discuss this in detail when I'm teaching the course. Now, this hydraulic sheet for SUSD. SUSD stands for step up and step down procedure. This is basically the method when you are doing the step up, step down in MPD. It's about like how do you trap the friction when you're making the connection. And that's to do with the data capturing of step up, step down. Remember, step up and step down is done on a single flow rate. And I believe, if I'm not mistaken, the flow rate here, because we were doing a 6 1/8 inch hole, the flow rate here is 260 GPM. You can see that, and you can see this is when you were drilling. This is while you are drilling, and this is when the pumps are completely off. Sorry. Now, this tab here is to do with the ECD data. So let's say, for example, if any one of you get into a situation where you have lost circulation zones on the top and high pressure gas zone at the bottom, then you may have to plot the ECD curves. So rather than plugging in the numbers into softwares and all of that, you can actually utilize your single phase hydraulics program in order to plot the ECD curve. These are the 2 ECD curves starting from the TD all the way down to the casing shoe. Now remember, this casing shoe is right on the top of the pay zone. In other words, the ECD curves are only presenting the open hole section which is being analyzed or which we are going to drill using the MPD application. One thing that I do emphasize is that the cased hole section does not really matter when it comes to MPD. It's the open hole area that we should be concentrating on. Now, here is the IPR for the risk. IPR stands for inflow performance relationship, and this is the chart that we have plotted for IPR. This is for a gas reservoir, so obviously we use a Fetkovich back pressure equation in order to plot the IPR. You can see this reservoir itself is pretty tight because the AOF value is standing at about 2 million standard cubic feet per day of gas. These three lines here are only for the risk analysis, because remember, we're not actually flowing the well when it comes to managed pressure drilling, okay? So all of these three mud weights, or all of these three pressure lines that is showing, it is basically describing the static bottom hole pressure. It is not with the APL. So what I have done in this analysis, I did not add the APL into it. However, when you come into the class, I might ask you to add APL into this as well. And we will discuss this more later. This is to do with the fountain curve well section, one of the exercises that you will have to do in the course. And then once you have done the well sketch, this is once again a single phase hydraulics program for fountain curve analysis. This is just for the data capturing, and this is the fountain curve method. So you can see this red dotted line is the fracture gradient, and the blue dotted line here is the pull pressure gradient. So in other words, this is more to do with a walking the window type application. Now the last tab, you will not see anything here because this is your final exam. In the last tab, this is the level 1 method. And I wrote an article on level 1 last year. It was published in the Drilling Contractors magazine. So if you search about it, like a novel approach to analyze MPD well sections, you will be able to read this this method. However, we will do this method as a final well design in the course. And this is to do with the IME analysis, which is called influx management envelope. This is the well, this is the section, or this is the well design for the IME, and that's the IME hydraulics program. Once again, hydraulics program. That's the IMETD analysis when the gas is encountered at the toe of the well, and this is the analysis when the gas is at the casing shoe, and this is the final analysis using the IME curve. So you can see like the TD curve is right on the top and the casing is just below the TD curve. And this is it. So you will be fairly busy for the next 4 to 5 days, in which we will be utilizing this workbook. Now, one thing is for sure, that in this course, you will be a master when you will come out using the single-phase hydraulics program. And what would it do? The benefit of using single-phase hydraulics program in Excel is that it will allow you to stay, you know, like sort of like you can use this single-phase hydraulics program rather than actually using the software. If you are if the software is handed to you like WellPlan or like WellFlow 8.3 or any other software which is to do with hydraulics, yeah, you know, you're welcome to do that. The same analysis over there as well. But how about if you are on the rig side and you don't have access to the software, then this type of tools built in Excel are fairly handy. So this is a small introduction about the MPD, Managed Pressure Drilling Workbook, which I have created, and I talk about this in detail in the course that I teach on managed pressure drilling and well control dynamics.